Okay, so hi guys. I'm so sorry for the lack of videos or the lack of uploads. I've been just still recovering. I was put on antibiotics, so um yeah. I wanted to make a really quick video, or hopefully it's quick, over over how to do this problem. It says use the fundamental theorem of calculus part 1 to find the derivative of the integral. So this is I wanted to do a problem like this because this is something that I personally forget a lot, and I'm sure that um, many of you as well have a hard time with these. So to kind of, you know, um, to kind of make it very clear on how to do these, I decided to make a video because this is a topic that I personally always forget how to do, and I just think it'll benefit you guys who are in calculus. So, okay, so we have the integral from 4 to the square root of x plus 2 of the quantity t squared over t squared plus 1. So, the idea is, and I'm going to write down the rule, and the way that they explain it in the book is not, I mean, it's the right way, it's the correct way, but I like to use a different notation for it. I will write down the way they explain it in the book, and this is on the calculus early transcendentals. Sorry for my handwriting, guys. Early transcendentals. So, give me a second. Okay, so this is the book I'm using. It's Calculus Early Transcendentals, 8th edition by James Stewart. I did not get this example from that book. At least I don't think I did. I made it up. But this is kind of the book that I'm using in case anybody wants to, like, buy it or rent it, whatever. And I will post a link to that book, or put the name of it in the description so you guys can kind of look it up. So yeah. So we have this problem, and I would have to write down the formula, or the definition, and this is why I got it from the book. And it is gonna be, I think it goes, when we have, let's see, the integral from a, let's do from a to x of f of t dt. This is equal to, and this is actually going to be equal to, and I'm going to highlight this part, it's going to be f of x. Something like this, right? And also, it's times the derivative of x. So that's the one thing they don't put in there, which, of course, it was confusing at first because, well, yeah, and so, the derivative of x. So, of course, I guess the reason why is because this whole thing, well, actually, this is the formula for it. The way they explain it in the book, guys, it's like a to x of f of t dt is equal to f of x. That's really how they say it. I'm pretty positive that's how they say it. So we're gonna go ahead and I have another way of saying this, and I want to go ahead and write down my kind of the way that I saw it personally, And not that I'm trying to say that the book doesn't do a good job of explaining it, but I feel like this notation is a lot more, it's a lot easier to remember. So if we have f of, let's say, from a to f of, actually, let me do from a to, let's do, to u of x, right? Let's do from a to u of x, and then of some function, let's just say g of t dt, then, you know, if, and I put if f of x is equal to this, right? So if f of x equals the integral from a to u of x of g of t dt, then, I'm going to write then f prime of x is going to be the following. G of, and it's g of, and we're going to put u of x, right? So g of u of x times the derivative of u, so times u prime of x. I want to say basically you're plugging, kind of doing composition of functions here where you plug in t is equal to u of x, basically. So I can say where t is equal to u of x. Basically, you're doing composition of functions, just plugging it in and then taking the derivative of u. Now we're going to look at the problem that we have. So if that explanation's kind of long, I do apologize, guys, but I want to make sure we understand. So using that definition, we're going to go ahead and we have the integral of 4. So it's going to be from 4, and I actually forgot to put one thing here. F of x equals, sorry guys, I forgot to put that in there. But basically, if I know that f of x is equal to the integral from, let's do, and it was from a to x, so it was from 4 to x plus 2, so we have 4 to the square root of x plus 2, excuse me, not x plus 2. So to the square root of x plus 2, right? And it was of the quantity, and it was t squared, so it was t squared over t squared plus 1 dt. Right. So then what I'm going to do here, I know that, like I said, g of t, my g of t is t squared over t squared plus 1. That's basically what this stuff is here. And now what I'm going to do is I'm going to evaluate, because I know that u of x is square root of x plus 2. So what I'm going to do here, and what we have to do here, is we need to go ahead and evaluate. So we have to put u of x in for t and g of t. So we're going to do, so this is going to be, this whole thing is going to be the following. It's going to be g of u of x, and then we're going to do times the derivative of u of x. So it's going to be times u prime of x, which means we're going to have to differentiate this, take the derivative of it. So then we have g of u of x. So now if I go ahead and do that, like I said, g of t was t squared over t squared plus 1. G of u of x is really g of, and it was square root of x plus 2, right? Because u of x was square root of x plus 2. And so I go ahead and say the following. This is going to be the square root of x plus 2 quantity squared over the square root of x plus 2 quantity squared plus 1. So I'm just plugging in for t the square root of x plus 2 and evaluating. And now this becomes, so the square root of x plus 2 quantity squared, that's just x plus 2. And it's the same thing on the bottom, but we're adding 1 to that. So x plus 2 plus 1. So I get x plus 2 over x plus 3, right? Okay. Now, so now we found g of u of x. So now I can go ahead and say that g of u of x, this entire thing is really just going to be x plus 2 over x plus 3. So I got that out of the way. And now the last thing we have to do here, guys, is to go over, or actually to find the derivative of u of x. So like I said, we know that u of x was square root of x plus 2. So u of x was square root of x plus 2. So now u prime of x, well, if you think about it, d dx of the square root of u, I'm sorry, d du, excuse me, it's going to be 1 over 2 square root u times u prime being the derivative of u. But in this case, I mean, obviously, it would be the following. So it would go 1 over 2, and it's whatever's inside of this. So it's going to be times the square root of whatever's inside of this, whatever's inside that square root. So that's going to be 1 over 2 square root of x plus 2, right? And then, and then times, and then the derivative of x plus 2. The derivative of x plus 2 is just 1, so we don't really have to put anything for that. It's still 1 over 2 square root of x plus 2. So now we're going to put it all together. So now we have g of u of x, and it's going to be times u prime of x. And so the way this is going to be, and this is the part where it gets a little bit tricky, but I'm going to do my best to explain it. So we have to do a little bit of algebra at this point. So we're going to do, let's see here. Hold on, guys. It's going to be, so that was u prime of x, right? And so now we're going to put it all together. We need to, so this is u prime of x, of course. And now we have g of u of x. So g of u of x was x plus 2 over x plus 3, just this part. So it's going to be, again, g of u of x times u prime of x. And that is going to be the integral. I mean, obviously, that's what that's equal to. It's going to be the integral from 4 to square root of x plus 2 of t squared over t squared plus 1 dt. Is equal to this. And so, like I said, g of u of x was x plus 2 over x plus 3. So times the derivative of u. Like I said, it was 1 over 2 square root of x plus 2. Now notice one more thing, guys. This is properties of exponents. This is x plus 2 to the first power. And it's times 1, so we don't really have to put anything there. And then this is going to be 2 times x plus 3 times the square root of x plus 2. But notice that the square root of x plus 2 from algebra, remember, if you remember from algebra, the square root of a is really a to the 1/2. So this is going to be x plus 2 to the 1/2 power. And using laws of exponents, this is going to be x plus 2 raised to the 1 minus 1/2, because we used the quotient property. Remember, a to the n over a to the m equals a to the n minus m. So then this becomes, give me a second, guys. This becomes this, and then we have over 2. Oh, and also, yeah, over 2, and it's going to be times x plus 3 times x plus 2 to the 1/2. So this is x plus 2. I'm sorry, excuse me. 2 over x plus 3, because, like I said, we did properties of exponents right here, and it gave us this. So we don't have to put anything there. Now, this becomes x plus 2 to the 1/2 power over 2 times x plus 3. You can also write it as the square root of x plus 2 over 2x plus 6, or the square root of x plus 2 over 2 times x plus 3. You can also say x plus 2 to the 1/2 over 2x plus 6. It doesn't matter. They're all the same. Any of these answers works, guys. I do apologize if I rambled a little bit. This was a long problem. I wanted to make sure that we understand the property, the rule that we're using for these, and I really wanted to make a video because I know these are pretty tricky. The part 1 fundamental theorem and part 2 are kind of different, so we want to make sure we understand those two concepts. But with that being said, guys, that is going to be it for this video. And also, thank you so much for watching, and please like, comment, and or subscribe. And I will see you guys in the next video. Bye, guys.